Hey, we're continuing to chug through chapter 2, and today we are going to focus on parallel and perpendicular lines. So, whoops. So what are you going to see in this video? Okay, so a couple of things we're going to look at is, can you find, if we are given an equation, could you find the slope of a line that would be perpendicular to that one? Another scenario is we're going to be given two separate lines, and we're going to try to determine whether they are parallel to each other, perpendicular to each other, or neither. And last but not least, we're going to try to write the equation of a line, which builds real nicely onto our previous lesson, 6, if you're following through on the playlist here. And we want that line to pass through this point, and we want it to be parallel to this equation right here. So we've got our hands full tonight, no doubt. So the first thing we want to be able to visualize is, do we have a strong visual of parallel lines? It's kind of like two train tracks that run alongside each other and never intersect with each other. And the beautiful thing about parallel lines is they have the same slope. Their slopes are going to be equal to each other. And that's what we're trying to say here in this notation. The slope of the first line must equal the slope of the second line. Now, the other variation we're going to look at today is if two lines are perpendicular. In other words, they definitely do intersect each other, and they intersect each other in a really special way. They intersect each other at right angles. So we have a 90-degree angle right here. And in this particular case, their slopes are opposite reciprocals, or sometimes we say negative reciprocals of each other. So if we've got the slope of the first line, the other one is going to be the reciprocal negated. So let's look at a few examples of both parallel lines and perpendicular lines. In our first examples here, if we compare this line with this line, the beautiful thing is they're already in slope-intercept form. So we could say the 2 is my slope. So the slope of the first line is 2. And over here, again, we've got a slope of 2. So the slope of the second line is 2. Therefore, they are parallel. The fact that I had a y-intercept of 5 here and negative 6 over here has no bearing or influence on whether they're parallel or not. Now, this next example is going to make us work a little bit harder. All right. We say, okay, here's my first line. Is it really parallel to this line? They don't look like they're parallel right now. But what you want to do is solve for y. So in this case, I'm going to divide every term by 3. And that's going to make y equals 2/3 x minus 1/3. So his slope is 2/3. Over here, we're going to divide everybody by 6. And we get y equals, now that 4/6 reduces to 2/3. And so the slope of the second line is 2/3, and because they are the same, these lines are also parallel. Now let's look at some lines that might be perpendicular to each other. So again, this first example is really nice because the y is already by itself that we see here. So this line has a slope of 3. This line has a slope of negative 1/3, and these are examples of two numbers that are opposite reciprocals of each other, or negative reciprocals, and therefore these lines are perpendicular. Maybe, you know what, let's take a moment and just practice negative reciprocals. If I had 2/3, the opposite reciprocal would be negative 3/2. Or if I had, let's say I had 5/4, the opposite reciprocal would be negative 4/5. Or maybe we had negative 3/7. The opposite reciprocal would be positive 7/3. So let's take a look at this next example where the y's are not solved for. This first equation, we'll divide everybody by 4, making y equals 5/4 x plus 3. So therefore, the slope is 5/4. Now, what I'm kind of anticipating here is that the slope of this next line is going to be negative 4/5 if they truly are perpendicular. Let's see if that's what we get. Let's divide everybody by 5, and y equals negative 4. Yep, there it is, negative 4/5 x minus 4. And since this guy has a slope of negative 4/5, these slopes are negative reciprocals, and the lines are perpendicular. Okay, so we're going to try to find the slope of a line that's perpendicular to this bear. And so I think the first thing I'm going to do with that equation, I'm just going to, well, let's rewrite it first. I'm going to subtract 6x from both sides. I get negative 2y equals negative 6x plus 3. Now I'm going to divide everybody by negative 2. And that's going to leave me with y equals positive 3x minus 3/2. So the slope of this line is going to be positive 3. The opposite or negative reciprocal of 3 is negative 1/3. And that would be the slope of a line perpendicular to the given one. In our next example, we've been given two lines and we want to determine whether they're parallel, perpendicular, or neither. So let's start with this first equation. Negative x plus 4y equals 10. Let's add that x over, and let's divide everybody by 4. So I got y equals 1/4 x plus, now that 10 divided by 4 is going to reduce to 5/2. So we do have a slope of 1/4. Let's take a look at the second line, 3x minus 12y equals 4. First thing I'm going to do is just subtract the 3x over. Then we could divide everybody by negative 12. Now negative 3 divided by negative 12 does reduce to 1/4. And 4 divided by negative 12 reduces to 1/3. His slope of this line is 1/4. Now, because these slopes are the same, our conclusion would be that these lines are parallel because they've got the same slope. All right, our last example, our grand finale tonight is, can we write the equation? And I'll tell you what, to be honest, when I see this phrase, find the equation, the first thing I think of is my point-slope form. This is really probably my favorite version. So I've got my first x, I've got my first y value. Those can substitute here and here. And we need to be parallel to this line right here. So I need to find the slope of that line, and then I can substitute it for m. So let's follow this equation. 4x minus 5y equals 10. Let's subtract that 4x over. And then we're going to divide everybody by negative 5. So I get 4/5 x minus 2. And the slope is going to be 4/5. Let's go ahead and sub that in. Y minus 5 equals 4/5 quantity x plus 2. Now the reason I wrote plus 2 is because it was technically x minus negative 2, and those two negatives made a positive for us. Now for me, this is totally acceptable. I could stop right there. Depending, just be careful with the directions. They may ask you to clean that up a little bit and express it in slope-intercept form or standard form. In that case, we'd have to distribute the 4/5 and try to, wrestle with those fractions a little bit. But I'll tell you what, I think we're feeling pretty good, and no matter what they throw at you, you're going to be ready for it.